Dr. Bilec has over 60 publications and tons of money in funding. She's also received multiple Career Excellence Awards in teaching, and we're very happy to have her. So with that, I'll turn it over to her.
Thank you, and thank you for having me here today. And so the title of my talk is, Are We Using Buildings to Inspire and Motivate Health and Sustainability? So a pretty lofty title. And one of the, can you see this? Yeah, turn it. Thank you. It's such a great picture. I hope you, that's a little bit better. So hopefully, oh, that's great. So who's been to Florence? Okay, so we have about half the people have been to Florence. Actually, I was there with Amy, and it was one of the reasons why I like to put this picture up is because this particular building is one that really inspires me. So I read all the time, and I really like to read about different prolific eras and times. So one of the most prolific eras is the Renaissance. And in this particular building, what inspires me the most is that when the building was being built over hundreds of years, they realized that the space in the middle for the dome, they didn't know how to actually make the dome to stay in that space. But they said, it's okay, somebody will come along and figure it out. So it was a really, I think it's inspirational because during that time, the people had faith in humanity, faith in science, faith in art and architecture. And guess what? Somebody did come along, although he had to fight a lot of the time, and to figure out how to actually do that. And his name was Brunelleschi. And if you haven't read the Ross King book, I recommend it. It's a really, really great book. I've read a lot of the Ross King books. But not only did Brunelleschi figure out the design of the Duomo, but he also had to figure out, where am I going to get the materials? He had to design the equipment to hoist the materials up into the Duomo, and he had to keep the workers safe. So for example, if they were going up really high, they only got a quarter of their wine allotment for the day, and the rest of it was watered down. And so this was something that has really inspired me. And especially if things get negative, I always try to think about these like inspirational types of buildings. The other building that has really inspired me has been a children's hospital that I've worked on for many years. This is a children's hospital in Pittsburgh, and if you have kids or if you've been to a children's hospital, this is one that I'm personally really proud of. It's a green children's hospital, and there are so many different design elements in it that really try to foster a sense of not only healing for the child, but a healing for the family as well. And if you go to a hospital with a child, there are a couple things that are really important. One is control, because you feel a lack of control. So there's elements in the design that accounts for that. And also a sense of transformation, because you're going there for a transformation. So that design has really been emulated, and those thoughts have been emulated throughout the design. And so you can see here, and I'll point this out because most people won't see this in the first glance. So there's this really beautiful wooden kind of sculpture right when you enter. This is the registration point where you enter. And so because the acoustics are difficult, it really helps to direct the conversation down, so there's a little bit more privacy at the entrance desk. But most importantly, is there's different heights. So this is for the parents, right? But this is for the kids as well. And so the designers actually considered when the child goes into the hospital too, they have a sense of a lack of control, and making that connection in the beginning is a really important element to it. And right over here is for the siblings. There's a room for siblings that are dealing with any sort of issues with their family. So it's a really thoughtful and inspiring design. And this is another element of the design that I like. This is they do movie night here. They do different dances, and if you're compromised, you can actually still see and participate just on the upper levels. So you're really trying to create this inclusive environment in a difficult situation. And again, one of the themes that comes through in the design is this idea of transformation. So you'll see the different butterflies and elements of transformation that really represent what you and your family are going through. The third and final kind of inspirational building, and I'll talk about this because I was able to work on different research projects as well, is the Center for Sustainable Landscapes. And I've worked on this building since since about 2007. And this is, I will say, one of the greenest buildings in the world. It's a net zero energy building. It's qualified for the Living Building Challenge. It's a LEED Platinum building. It was a Sites Initiative building. And it also has a WELL status as well. And so this building has been a really great project to work on, and the FIPS organization has opened it up to the community and to researchers because they want to learn how to improve their sustainability efforts as well. And this is inside the space, which is it's a beautiful space. And they're currently working on different elements of biophilia and how they can incorporate biophilic design into building design. So we saw all these gorgeous spaces, and one of the things that we think about is, buildings really can and do inspire us, but we can also work in environments like this as well, too, right? And we may have all had offices or currently have an office that looks like this. And that can actually impact our productivity, our quality of life, our health. And that's really at the heart of what I'm trying to understand in my research group. These are some slides from Architecture 2030. And, so not only do buildings impact our health, but they have significant environmental impacts as well. So buildings consume nearly half of all the energy produced in the US. And buildings are responsible for nearly half of the US CO2 emissions. So we've all probably heard or seen statistics like that before. And one of the things I think is important is to start to bring these statistics into different visualizations so that people really understand this impact of carbon dioxide emissions. So these are some images. Ed Mazaria did this with Christina Kirchner, of what the different cities would look like at certain sea level rises. But more compelling is, I don't know if you saw this, but there was a resettling of the first American refugees series that the New York Times ran. And this really struck me to see that we have climate refugees in America. Really kind of struck me, and the images of that series, I think, stayed with me as well. So these are people's homes they're leaving that are being destroyed, and they need to move. So what about these buildings? So as of 2010, the total U.S. building stock was approximately 275 billion square feet. During normal economic times, we tear down approximately 1.75 billion square feet each year, which is kind of hard to understand. And every year we renovate approximately 5 billion square feet. So for civil engineers, this might be a good thing. And every year we build new approximately 5 billion square feet. So by the year 2030, approximately 75% of the built environment will be either new or renovated. And so this transformation over the next 20 to 25 years really represents this historic opportunity for us to think about what we can do as engineering professionals to really impact and avoid climate change issues. So then I start to say, well, what can we do? Are we as a profession really ready to address this? How can we help? And one of the things that I think is really important and that I learned from one of my co-advisors is that we have to ask the right questions. And so some of the questions that we ask in our research group is really at the heart of it is to say, are we on the right track? Are we aiding in this process to reaching these opportunities? So our existing policies, programs, and systems aiding in creating our healthy and sustainable buildings to really combat some of the critical issues that we have to fight with today. The other thing that's really important is that we need to use the right approaches. And so I use life cycle assessment and employee systems thinking. And the other thing that I do in working with buildings and communities is to consider multiple scales. So I'm going to show you a little bit about some of the work that I get to work on. And I try to show this across different scales, although this figure never comes out just right. So at the system level, what I do is I work to think about ways to enhance the current life cycle assessment model for buildings. Without getting too in the weeds, one of the failures of life cycle assessment for buildings is that everything that happens in life cycle assessment is external to the building. So global warming potential for the most part, so acidification potential. But we don't incorporate the emissions and the impacts of people inside the building. So we've been doing that in our research group to really incorporate indoor air quality into the life cycle assessment framework. I get to work on green buildings and green communities. So this is a picture of the Phipps building again, but I'm also working on the 2030 district, which is an energy conservation district in Pittsburgh, where over 70% of the central business district has committed to aggressive climate, energy, and water goals. And so we're providing services and research to the 2030 district. I get to think about construction and processes, where I really spent a lot of my PhD on. And I also get to think about performance metrics and energy modeling. And so if we go back to that Children's Hospital project, just to give a little bit more depth here, what we were trying to really understand is we had that old Children's Hospital. It was actually two blocks away from where I work now, and it moved into this new green hospital. And we wanted to know, like, what was the difference? Did this green hospital do anything? And so we collected all these metrics. We collected things like turnover rate for nurses, mortality index, utilities. We collected all of this information, and we found that from an energy perspective, the building was performing better. But most importantly, and this is when the research really kind of hit home for me, so we collected this data from 2004 to 2012. And I know this is a little bit confusing, but what we found is that the types of cases that were coming into this new hospital were more critical. So when someone comes in, you say, I give them, and I know this is actually really hard to hear, I give them an X% chance to survive. And that's one of the things that's recorded. So the cases were more critical, but the outcomes were better. So less of the people that were entering the hospital were actually dying. And so what we were able to elucidate from this work, so we did survey work and we did focus group work, is that the folks basically said that the hospital really catalyzed their work environment, and that the elements of the green building, through the healing garden, through the different aspects in the MRI rooms, the whole atmosphere really tried and helped to enhance the quality of work that they were doing. And we got to work with the vice president of nursing on this project, which really helped to give an inside track too. And I've also done work with life cycle assessment, understanding how can we make our lowest performing buildings perform even better. And so we looked at different ways to do that as well. And so I use life cycle assessment, but the other tools that I also use is we do energy models, we do indoor air quality assessments, surveys, and focus groups. And I've recently been doing more work on resilient and sustainable buildings. We have an NSF RSV project that I'm working on with Penn State to understand kind of the environmental impacts if you have a disaster. And I couldn't do this without my amazing students. And every time I look at this picture, and I'm sure many of you feel the same way about your students, is every student has a special story, and that really stays with you. At least it stays with me throughout my time as an academic. So, for example, Cassie started out, I think about 2010. She's a professor at NYU now. Kevin just finished. He's working in Boston, and he's doing residential energy assessment. So I've really had a great group of students. So getting back to the question, Are existing policy programs and systems aiding in creating healthy and sustainable buildings? I really want to talk about the systems perspective. And I wanted to talk about the question of how is LEED doing? So does everyone know what LEED is? Everyone knows what LEED is, okay. So LEED is a green building rating system, and it's one of the most subscribed to internationally. And there are other green building rating systems. So for example, the Living Building Challenge is another green building rating system. There's BREEAM that came out of the UK. There's CASB. There's WELL. And LEED has really evolved through several different versions from 1998 to 2013, and I'm sure there will be another release. And it definitely is kind of the dominant market force in the US, especially driving green buildings. And one of the things that the USGBC, the United States Green Building Council, is trying to do is to expand internationally. And so we were wondering, does this really make sense to expand internationally? So I'm going to start to give you two perspectives on the direction that we're going in terms of green building ratings and green buildings. One was on LEED and renewables. And so the IEA actually predicted a growth in the renewable energy in all sectors, but the highest growth in the building sector. So if you think the IEA is saying that if we're going to have renewables, the highest sector that we're going to have increases in is the building sector. And some people would say that buildings could potentially really advance technologically as well. And one way to foster this is really through green building rating systems like LEED. So what's going on in LEED? And I know this is a little bit hard to read, but just follow along with me. One of the things that we are seeing is that the weighting or the kind of carrots that you're getting in LEED for renewables is decreasing. So, for example, in this particular one, the renewable requirements was at 20%, and then in the LEED V4 it went down to 10%. So it's a significant kind of change, right? So if we have this potentially driving market force, but we're not in alignment, there could be a disconnect. And so there's more information on the top paragraph. But what we really wanted to understand is what then is the potential that we're missing? Can these buildings that we're creating actually have more potential for on-site renewables? Or is this something that we don't know? Maybe the buildings really don't have that potential. What is the real potential that we're missing? And part of this work was born out of the work that Laddie Klotz did. And he's at the University of Virginia, and he looked at unintended anchors. So what Laddie and his team was saying was that the building rating systems are actually creating anchors, and that if we set potentially higher bars, then the buildings in themselves would actually achieve those bars. So that's what we're saying. We're saying is, from the renewable perspective, are we setting these bars too low? Do they need to be higher? And in that process, what can they really reach? So what we did was we set out to kind of figure this out. And we had this building information model that we used in another paper. And we took this building information model and we changed it. We changed it to meet the codes and other different requirements in 25 different locations throughout the world. And when we did that, we also made sure to look at the energy sources for electricity and natural gas throughout the world to make sure that we really understood the potential environmental impacts of the buildings. So we looked in places like Russia and Hawaii, and you could see some of the other places. And then after that, after we situated this building and changed the design appropriately, we used Autodesk Green Building Studio to then understand the energy model for the building. So how much energy would the building be using in those locations? And not only that, what was the potential for on-site solar and wind. And we specifically use Green Building Studio. There are other different tools that we could use, but we use Green Building Studio because it's a commonly used package used in architectural firms. And so we wanted to see what would people in industry be doing. So finally, some results. So what we found, and I know this is a little bit busy, but the bottom line, and I'll go through a little bit more, but the thing to remember is that all except 5 buildings were able to produce over 10% of the requirement in LEED. And so we constrained that as well. We said we have to think, you know, would this make sense in terms of an economic perspective? Like, you know, we could say that they could produce this, but does this make sense in an economic perspective? And even with those constraints, of the 25 buildings, only 5 did not meet our constraints. And some of the things that we found that were really interesting, for example, if you take Hawaii. So Hawaii, obviously you can create a lot of solar electricity in Hawaii. And not only that, the cost of electricity in Hawaii is really high. Therefore, the payback period was lower. Okay, so it would actually make sense to do this in Hawaii. In another place like Chile, it wouldn't necessarily make as much sense from an economic perspective, because in Chile, while you have a lot of solar potential, the cost of electricity is actually pretty low. And there's other nuances to the study, but the main point is that, you know, just from the sample of 25, we really were able to then say that yes, the requirement is really holding anchor. So the takeaway message is that we really think that if the USGBC is to expand internationally, and if buildings are really going to reach their potential in terms of solar production, we need to think about removing the anchors and aligning the potential. And I have done other critiques on LEED as well. This was one of them. The other perspective, because I want to be positive and I don't just want to be a naysayer, is some things that may be working. And so these are just 2 buildings, and we submitted a paper on this. So I have the Phipps building here, that we talked about. Oh, and I did remember all the right rating systems. And then we have the building that I'm in. This is the Mascaro Center. And just so everyone knows, it is never that sunny in Pittsburgh. This is like the one day that Sunny and all the professional photographers go out and get all the pictures. And so the difference is pretty interesting. In the Phipps building, the occupants are really engaged in the operation of the building. So for example, they can change the set points of the building. I'm too hot, I'm too cold. They can open the windows. They can work in different spaces. And in my building, which is a LEED Gold, we have no control over our space. Well, none whatsoever. We can't open the windows. We have this like fake thermometer on the side, which I really don't think does anything, which you know what I'm talking about. And so what does that tell us? So this is the Center for Sustainable Landscapes. This is predicted PV production versus actual PV production. Okay, so this mapped really nicely, right? So which is a good thing. This is the amount of the electricity that the Center for Sustainable Landscapes used versus predicted. So for example, the black is the predicted and the blue is the actual. So in some cases they used more, but then they were able to readjust. And you could see, like in later months, they were actually able to change their set points on the air conditioning so that it was warmer and people tolerated that more. And so in the end, you end up looking like something like this. So you have the net actual versus the net predicted. And so, for example, in these certain months, the actual has exceeded the predicted, but in other months it has flipped. But in general, this has worked. And part of the reason why it has worked is the Living Building Challenge sets up strong kind of guidelines. where the LBC will say, you have to meet net zero energy. That is your goal. You have to meet net zero water. And there were organizational and cultural shifts that occurred. Okay? So the FIPS really subscribed to it. We already talked about the set points, and there's passive ventilation, and I have a question mark to that. We'll get back to that. So this is my building. So this part right here is what is from the energy model that was done at the end of design before construction. So you can see it's pretty flat. And then all the kind of spaghetti is what the actual is. So you could see in many instances we are well exceeding the energy predictions. Okay, and with LEED, once you get your certification, you're done. Okay, so we are well exceeding in many areas. And if you think about carbon dioxide emissions, if we were to stick with the design model and predicted that over time, we would have had this black line. But the reality is we're actually on the blue line. So we're significantly higher in our carbon dioxide emissions as well. And multiply that by the thousands of LEED buildings, it starts to add up. So what I have found is that the LBC is actually doing something that's, I think, a really positive step, that they're setting aggressive goals. And I think that in the LEED building, there needs to be more work done. We have no control or no autonomy over our spaces. But I wouldn't be an engineer if I didn't have a big but. So there's a but to this. So if you remember, there was the passive ventilation. The one thing that our building is doing really well is the air quality in our building. So this is looking at the indoor to outdoor ratios for particulate matter, and I won't get into the nuances, but basically we are not letting a lot of outdoor air coming into the space that's not cleaned. And so we do have an advanced filtration system. The Center for Sustainable Landscapes, however, they do have passive ventilation, and they can let a lot of air into the spaces. And you'll see that a lot of the external air is coming into the space. So what's the problem with that? The problem with that is that Pittsburgh has really poor air quality. We're the 6th worst in the country for particulate matter, and we have non-attainment for PM and ozone. And so while we are doing improvements with energy, we have to do that in the context of the environment that we are designing in. And this is not just this building. This is a new gorgeous building. It's a PNC. It's called the Tower, like Lord of the Rings, but it's called the Tower. And the building has a double skin on it to allow for passive ventilation to occur. And the control system is with the Allegheny County Health Department air quality index, but there is not an air quality monitoring station in town where it's located. And so there's a disconnect, right? There's a disconnect, and it's a beautiful building. And so one of the things that we're considering and we're trying to do more research in is to say that we have to consider the trade-offs between passive strategies and energy efficiencies, especially in regions of poor air quality. And not only that, is if you have these controls and sensors, to use them effectively, and to really integrate that with the building automation system and the design. And so I'll end where I finished. Are existing policy programs and systems aiding in creating healthy and sustainable buildings? I think we still need to continue to ask the hard questions and to use the right approaches. And that we really do have this historic moment to think about what we want our next generation of buildings to look like, and what we as engineers really want to be a part of. One of the things I talk about in my class is largely we are responsible for a lot of the environmental issues, and I do believe that. But we also have a huge chance to make a difference and a huge opportunity to make a difference too. And so with that, I'll thank Amy, one of my colleagues, Sammy, who did the lead work, and Bill Collins, who did a lot of the work related to the two different buildings. So thank you. Any questions?
Do you know why LEED is decreasing the weighting for renewable energy use?
Okay, so this is a really good question. So when LEED, the latest version of LEED was issued, they said that they used a weighting system developed by NIST that was applied to LEED. And if you look into the study that they cited for NIST, it was a very small group of experts. I think the sample was 18. So 18 people are deciding that weighting for all the different categories. And so I honestly don't know if they're really using the NIST study or if they're just justifying it with the LEED study. But one of the things that I've observed with the USGBC over the years is because they've become such a market driver, they've also been subjected to significant lobbying efforts from different industries. So that may be part of it as well.
I guess there are a couple of questions. One is, what are the lifetimes of some of these buildings? And, so we're in a bad air quality situation. We're going to avoid passive techniques, perhaps avoiding getting particulates in. But 30 years from now, the air quality is better, the building's still there. So now you're kind of opportunity lost of sorts. And climate change may also be such that your efficiency needs might vary regionally over a 30-year. So a big building like you showed, hopefully there's more than a 30-year expected life. But are you kind of stuck in today's technology 30 years from now?
Okay, so lifetime, I feel like I could spend a lifetime thinking about lifetime and life cycle assessment. And so, and that's especially true when you're thinking about risk and resilience and how to think about design life and target life and things like that. But I think the heart of the question is, to me, thinking about how changeable a design is of a building. And so, for example, the PNC Tower is a type of building where the space in and of itself is conducive for different types of change. And I think especially the organization would be open to different technological advances as well. And so we don't know what's happening in 30 years, but I think certain buildings can be designed so that they're more amenable to different changes, both cultural changes and technological changes. And one of the things I really think we need to think about in buildings is that we are spending less and less time in our formal workspaces. And in Europe, it has even increased. So what are we doing with all these spaces? Like, what should we be doing as our culture shifts to more transient workspaces? I think that's a really interesting question too.
So, sort of piggybacking on Andrew's question, I totally agree with the idea that we're kind of anchored towards the LEED limits. Nobody's going to go above and beyond without a prize. And by lowering the limits, everybody suddenly gets a gold star, and that's like fun for everyone. So what does that mean for the future of like building certification? Are we going to lower the standards so everybody can advertise, or from an economics perspective, is it better to sort of push the envelope?
Yeah, so I would argue that there has to be more kind of personalization in green building standards for different regions. And that's one of the reasons why we started this study, because I know, like, our buildings in Pittsburgh are much different. Well, they're different from the buildings here or buildings in the Southwest. And then to take USGBC and to expand it to India or to Russia, like those things, that's when I was like, we really need to stop and think about what you're doing for a specific region. And I didn't get into a lot of details, but we looked at CO2 emission savings in different regions too, and how that could either constrain the design as well. The other thing is I really do believe that the LBC is pushing the Living Building Challenge, and the Institute for Living Futures is really pushing the envelope. And I'm very much encouraged by them. I'm not on their board or anything like that, but I love the work that they're doing. It's very thought-provoking and philosophical. And the WELL standard, if you have an opportunity to look at WELL, it's really taking the elements of your body and then trying to apply that to a building. So the ventilation system would be like your lungs. And I think that's an important thing to really connect our health with buildings. And so I think that that has some pretty high standards too.
You mentioned how many buildings per year are being torn down. I can't help but always cringe, and I see it a lot, where I live at least, how they're taking buildings down to build, better buildings. And I guess wonder, has anyone looked into the, impact of tearing down and rebuilding, and is it maybe more worthwhile just to kind of work on the renovation side, maybe people just make our buildings better? At what point is it are we just hurting ourselves by tearing things down and rebuilding?
So there has been a lot of studies that looked at like the embodied potential or the embodied energy in buildings, and especially historic buildings. And there's not necessarily like a clear answer. And so a lot of times what people will do then will run through like life cycle cost analyses to say, where will the new building be versus where a renovated building be that will potentially be less cost effective from an energy perspective. So I think that does become a little complex. But I think that also the question is not just an energy perspective or an energy savings perspective, but like the context and the importance of the building in the community. Like, does it represent something in the community as well?
Thank you for your talk. Really excellent.
Thanks.
To hear more about buildings. It's been a while for me. I'd like for you to talk a little bit more, if you can, about that community aspect. But there's a little bit of your later talk that you can bring in here. As like LEED buildings, where plenty of issues with LEED, as you discussed, but even this new LBC, like, are those for rich people only? And where does this fit in with that community? I know we talked about it a little bit earlier.
So one of the things I struggle with in saying, like, are these for rich people? I don't think that they are, mainly because the two buildings that I showed were, like, the one is the Frick, well, I didn't show this one, but it's a Frick Environmental Center, and it's run by a nonprofit. And then there's also the FIPS, which is run by, it's kind of like a nonprofit as well. So the costs were really a part of the equation. And to me, the most important thing is to have a really savvy design team that knows what they're doing, and then the costs won't be out of whack. I do think that WELL in particular has the chance to marginalize different communities. So I think WELL buildings have the potential to be more expensive. I just going through everything that you need to do, I really can see that they do have that potential. But I think there's a lot of elegance in the LBC because there's very few requirements, and everyone as an organization is working towards that goal. Did that answer your community? I don't.
Sort of. I guess the opportunities for community engagement with communities that wouldn't necessarily feel welcome, and I think that the FIPS when you had there's some potential there. Something you mentioned, like the landscape, and it's available for the community to enter. So what kind of happens there in terms of programming and those sorts of things? Benefits from that?
So the Center for Sustainable Landscapes is connected to the FIPS Conservatory and Botanical Gardens. So anyone that goes to the FIPS can also go into the Center for Sustainable Landscapes. The Center for Sustainable Landscapes does ProMat educational programming as well. So there are camps, K through 12 programs. Also, as researchers, you can work within the space. They do a science communication fellowship program. They've really opened the space up to the research community, and then the broader Pittsburgh community as well. And I would say more recently, they've focused on bringing in a more diverse socioeconomic background for their programming. The other building that I'm working on now is the Frick Environmental Center, and it's located in a city park that's open to the public. So anyone that goes to the park can go to the building, and there's actually an external water feature that the kids can go and play in, and the many, many days in Pittsburgh.
Do the people that are working on these standards and architects thinking about designing buildings, how do they connect that to larger community? How do they connect to larger collections of buildings as a collective? And there's lots of activity around smart city. Some of that's expanding to smart community in a residential way. Is there, is that going down a rabbit hole, or is that actually where it's going, and should it be going there?
So in these particular buildings, they were not connected. From an infrastructure perspective to say a smart city. They're definitely seen as like emblematic buildings in the community. But the 2030 district that I did mention, the Energy Conservation District, is a program that is open to the whole community. And so there are district partner meetings every month where we're presenting some of our indoor air quality work, or people are doing different best practices, and then we're working on cogeneration and smart grid issues as well as a community though. And so that to me is kind of the broader and better mechanism to talk about the different strides. And the one thing that I really like about the 2030 district is it's voluntary and not mandatory. And I think that's a really interesting model, because some cities are going towards like mandatory disclosure and certain energy use intensity, where in Pittsburgh it's voluntary, which I think we could have potentially bigger impact.
Yeah, I think though it begins to lead to another discussion, which is you have cities, you have kind of suburbia, and you have rural community. And I think your point about kind of regional standards for leads, that probably applies as well as to these different community types. I mean, we know that there are efficiencies when you collect people in cities that you don't get in rural places. And there's lots of buzz about half of the people in cities, but the other half don't. And, the community, the marginalization of individuals who are not connected. And so these are other maybe issues. We're starting to get some loose connections to something called Sterling Ranch, which is the biggest, only real major development going on, housing development going on in Denver. 12,000 homes. For those of you in the room, Highlands Ranch was 20,000. But this is right south and west of Highlands Ranch. And the CTO, the development company actually has a CTO. And all the homes are required to have a Siemens controller. There's fiber to every home. All the street lights are wired. They've got standards they're trying to force on the builders, but the builders are doing whatever they want because they can in the current environment. But while that all sounds well and good, to Greg's point, these are homes starting in the mid-440s. And then it goes from there, right? So it doesn't actually, I mean, there's definitely a socioeconomic stratification involved. And maybe that's where it goes. Early adopters are always more from the wealthy, perhaps.
Yeah, and I think part of it is, so that's in a new community where you have the ability to think about what a smart community could look like. One of the things that you could think about in an area that is not a developed area, like a lot of the Rust Belt cities, is how to take different technologies and then apply them to different transportation systems. So for example, in our city, we're working with the different controls for the intersections, and other cities have done that as well. So how do you take existing technologies and apply it to infrastructure that is already in place? And in doing that, you would help to then bring in more of the folks that may live further away.
All right.
Thank you.
Well, we'll thank you one more time.